got negative 3 arc tan x plus c, we will combine both answers, to which we will have 1/2 ln x squared plus 1 minus 3 arc tan x plus c. So now for our next example, we have the integral of x over 1 minus x raised to the power of 4. As you all can see, this is the arc sine u over a plus c. So we are finding here the a squared is equals to 1, a is equals to 1, u squared is equals to x raised to the power of 4. So we have u equals to x squared. The derivative of that one is 2x dx. So our dx here, we have du over 2x. So now we have 1/2 integral of du over square root of a squared minus u squared. So we're gonna substitute that into, or plug it in our arc sine. So we will have 1/2 arc sine x squared plus c. Okay, so now we have here a hyperbolic function. So we have sec h cube x tan hx dx. Just like what we did on our first few examples, since we have cube, we are going to separate it into two parts. So we will have sec h squared x times sec h x and tan hx dx. We will gonna let u as sec h As you all can see here, it is somehow similar to our first example, but this is now a hyperbolic function. So now we have u squared, so to which we're gonna be u2 plus 1, or u raised to 2 plus 1 over 2 plus 1. So we will have 1/3 sec cube h x plus c. So in this example, we have 1 over 1 plus sine h squared t dt. So as you can see, that it is a trigonometric identity, to which equals to cos h squared t. So it will gonna be 1 over cos h squared t dt. And this identity is also the identity of sec h squared. This is the reciprocal identity, to which will be the integral of sec h squared t dt is equals to tan ht plus c. We have cot hx dx. So the quotient identity of cot h is equals to cos hx over sin hx dx. So now we will get to use sin h as our u. So the derivative of sin h is cos hx. So now it will be easier for us to eliminate the cos h above the sin h. As we all know, du over u is equals to ln x. So we have ln sin hx plus c. So for our next example, we have the inverse hyperbolic function. U here is equals to 3x, or a is equals to 1. To which we have dx is equals to du over 3. That's why we have 1/3 sine h, or arc sine h, 3x over 1, or 3x plus c. For this example, as we can see, this is a arc cosecant. U here is equals to 2x and RA is equals to 1. Since we have x on the left side of our square root, we will use the u is equals to 2x to get the x, to which we will have x is equals to u over 2, so that we can eliminate the 2 on the u squared and the du over 2 above. Now we are plugging in our values into the arc cosecant, to which we will have negative 1 over 1 is equals to negative 1 arc cosecant 2x over 1 plus c. Okay, for our last example, we have integral of dx over square root of 4x squared minus 9. So u squared is equals to u, of course. U squared is equals to 4x squared, to which we will have u is equals to 2x, and dx is equals to du over 2. Our a here is equals to, since we have a squared as 9, so our a here is 3. So we will have 1/2 arc cos h 2x over 3 plus c. That's it for today's video.